Hello everyone, this is our Natural Language Processing course project. Here we developed Chatbot. We are a group of three, Maunika, myself and Sai Harshi. For developing Chatbot, we selected Natural Language Toolkit as our tool for text processing. Because Natural Language Toolkit is a powerful and versatile library in Python that provides us a wide range of tools and resources for working with human language data. And also, Natural Language Toolkit has libraries. Those are essential for natural language processing functionalities, making it suitable for a chatbot that needs to understand and generate human language. And the main reason for this is Natural Language Toolkit is a open source, so we can use it freely and available every time. And also, Natural Language Toolkit can perform several actions like tokenization, parts of speech tagging, name identity recognition, sentimental analysis, text classification, stemming, and lemmatization. First, we'll see one by one in detail. Coming to tokenization, Natural Language Toolkit can split text into words or sentences, as this is the fundamental step in processing any text data. And coming to parts of speech tagging, NLTK can identify the parts of speech in a sentence like nouns, verbs, adjectives, etc. And next one, name identity recognition. Natural Language Toolkit can locate and classify name identities such as names of people, places, or names of organizations in a text. Next, coming to sentimental analysis. In Natural Language Toolkit can determine the sentiment or mood expressed in a piece of text, which can be useful for understanding user emotions in a chatbot context. And next one, text classification. Natural Language Toolkit supports text classification, which allows the chatbot to categorize user inputs into predefined classes or intents. And last one, stemming and lemmatization. Natural Language Toolkit offers tools for reducing words to their root forms, aiding in text normalization. Not only these, Natural Language Toolkit can also perform several other actions like corpus and datasets, machine learning integration, text classification, chatbot rule-based systems, NLP research and experimentation, community and resources. Here, if we see, tokenization, parts of speech, tagging, stemming, and lemmatization comes under text processing, and named entity recognition, sentimental analysis comes under language processing. And if we see machine learning integration, Natural Language Toolkit can be integrated with machine learning and also deep learning frameworks, allowing developers to build chatbot models that can learn and adapt to user interactions over time. And chatbot rule-based system helps us. Natural Language Toolkit can be used to implement rule-based systems in chatbots so that we can define patterns and rules for chatbot responses based on the Natural Language Toolkit's capabilities. So that for text analysis and pattern matching. And next coming to bag of words model. In chatbot development, we used bag of words model. What is bag of words model? Here, if we see bag of words model is a technique that pre-process the text by converting it into a number of vector format so that it keeps a count of the total occurrences of most frequently used words in the document. And this bag of words model is mainly visualized using a table which contains the count of words corresponding to the word itself. In other words, if we see it can be explained as a method to extract features from text documents and use these features for training machine learning algorithms. And also, it tends to create a vocabulary of all the unique words occurring in the training set of documents. Coming to applications, we are using bag of words model not only in natural language processing, and also we are using it in information retrieval from documents and also document classification. The process involves initially cleaning the text, followed by tokenization, and next building vocabulary, and ends by generating vectors. Now we'll see the implementation part of a chatbot development. Over to you, Maunika.
Hello guys, now I'll show you the implementation of a chatbot. We have trained it on two intents, which is the hospital as well as order game data. And it has the following entities, which is for the hospital, we have diseases such as asthma, blood cancer, stroke. And for the consultation fee, we have given the following figures. And some example locations such as Kukatpally, Secunderabad, etc. And if the operation is required, yes or no. And for the game recommendation, we have chosen the entities such as genre, which is adventure, action, or board, and gender, male or female, platform, PC or mobile, and age, 18 plus, 13 plus, such like. And the recommendation chatbot recommends game or hospital according to the user inputs. Here, the RB main is the main file. Here we import session from RB session and we give a simple greeting, which is hi, how may I assist you in the initial. And when this is true, we fetch the replies for the user inputs from rbsession.py. Here we have four important functions, which is the input processor, intent identifier, check required params, and check actions, which is imported from RB actions. Here in the init method, we are initializing instances of this class. The session class takes two parameters, which are the attributes as well as active context. In the attributes, this is an empty dictionary. This parameter is intended to store information collected over the conversation. And the active context has both first greeting as well as intent complete. This parameter is intended to maintain active context during the conversation. Active context can be used to control the dialogue flow of the user. And now here we have defined update context as well as the reply, which the chatbot needs to give for user inputs. Now, if prompt is none, then self.context.name is intent complete. The intent completes over here and the chatbot exits. But if the prompt is hospital recommendation, the data is fetched from the hospital CSV, which we have trained the model. Same is the case for the game recommendation. So as you can see, the data is fetched from game recommendation.csv. And here, if the prompt is hospital recommendation, the chatbot checks the diseases, the attributes such as diseases, operation, consultation fee, and location. If all of the attributes are true, then the chatbot gives, we recommend you to join in the respective hospital. Else, if the prompt is game recommendation, the chatbot checks genre, age, platform, as well as gender. If all of the attributes are true, then the chatbot suggests us to play the respective game. Here in the RB actions, we have trained the model, which is here we have a pickle model over here, which is hash, and the check actions is defined over here, as well as the check required parameters. Here, this is the parameters configuration file. For example, if it is hospital, the parameters are diseases, location, operation, parameters are defined. So the chatbot asks for user inputs. For which problem do you need recommendation if it's hospital? And do you require any surgeries and further questions? And if all of the inputs satisfy, the chatbot gives recommendation from the actions hospital recommendations file. Else, if it's game, it checks the genre, gender, as well as age, and it asks the respective questions. And the actions are fetched from the game recommendation file. Now, here we have used the bag of words model to train our model, that is the chatbot. Here it checks the entities in this furlough, extract entity and update it in attributes dictionary. So it checks the entities and marks the entities. For example, operation, location, genre, all these are masked entities. So if you say, I need hospitals for asthma, that hospital is the entity value over here. So here we define the model. From NLTK, we import stop words such as a, as, the are the stop words in English. So we import stop words, and from NLTK, we import porter stemma as well. So from the queries data, we split the data, we ignore the stop words, and from sklearn feature extraction, we have imported count vectorizer, which converts the strings to arrays. So this calculates the occurrences of the words in the document. And here we train the data, test the data, and here we predict the output according to the user input. And by running this file, we can see the execution. Over to you, Harshit.
Hi, hello, my name is Harshit. So now I will show you the execution part. So we have developed the two intents. One is game and the second one is hospital. So let us first check on the game. Yeah, so it's showing like hi, how may I assist you? So for example, let us say that suggest some games. Yeah, it is asking genre. So let us type the genre adventure. Yeah, it is asking about the age. So let us give 18 plus. And it is asking about the platform. There are two platforms. One is PC and mobile. So let us give an PC. Yeah, and it is asking about the gender. So let us give a male. Yeah, and it is suggesting us to play a God of War. So let us search in the data. Yeah, it is showing the God of War. So according to the data, adventure 18 plus PC male God of War. So the given output is absolutely true. So let us give one more example. For example, yeah, same. Uh, genre is like action, age is 18 plus, platform is PC, and gender is male. So it is suggesting us to play GTA V. So according to the output, GTA V, it is a platform is PC, action is action, and 18 plus. So given output is absolutely true. So now let us check on the hospital. Yeah. For example, let us give an COVID-19 hospitals. Yeah, and it is asking about the surgeries. No. And it is asking about the consultation fee. So for example, let us give 1500. In which city location it is asking for, let us type Secunderabad. Yeah, it is suggesting us Gandhi Hospital. So let us check in the hospital data. Yeah, according to the output, Gandhi Hospital, Secunderabad, 1500 COVID-19. So it is the true. So the given output is absolutely true. So now let us take one more example. One It is asking about the problem. So let us give a asthma. So do you require any surgeries? Yes, yes. And it is asking about the consultation fee. So let us give 60,000. And it is asking about the locality. Let us type Warangal. So it is it has given the output. It is showing us to go for Samraksha Hospital. So according to the output, Samraksha Hospital, Warangal, 60,000, asthma, yes. So this is the execution part of our project. So thank you.